Hello.
All right, so we are doing lesson 26 today. Shh, listen up. And we are testing syllogisms by rules. So again, what I have put in bold and underline is what you should be writing down. Everything else I want you to know, but just follow along as we go. So there are 5 rules. 5 rules for testing the validity of syllogisms. We'll take a test a week and a half from now. You will have to have these rules memorized. They are not long, they are not difficult, but you will need to know them in order. So if a syllogism breaks even one rule, it's invalid. When you're testing syllogisms by rules, they got to go 5 for 5. If they go 4 for 5, it's an invalid syllogism. That's how easy this is. So if you want to establish the validity of a syllogism, you got to test it with the 5 rules. Because remember, all a counterexample can do is prove something is invalid. It can't prove it to be valid because maybe we just haven't thought of a counterexample. So we can never be absolutely sure, but we can with rules. So here are the 5 rules. I'm going to put them up here one at a time, so don't try to write them down right now, so don't worry about it. Here are the 5 rules. In at least one premise, the middle term must be distributed. Rule number 2, if a term is distributed in the conclusion, it must be distributed in its premise. Rule 3, a valid syllogism cannot have 2 negative premises. Rule 4, a valid syllogism cannot have a negative premise and an affirmative conclusion. Rule 5, a valid syllogism cannot have 2 affirmative premises and a negative conclusion. So here's what I do want you to write down on this screen. We can combine rules 3 through 5 into one rule. So here's a quick, fast, and dirty way for you to kind of evaluate syllogisms, like right off the bat. The number of negative conclusions must equal the number of negative premises. Now, that's a funny way of writing it. How many conclusions does every syllogism have? How many conclusions? 1. So what that means, guys, is that if you have 2 negative premises, can it be valid? No, because now you have more negative premises than conclusions. If you have an affirmative premise, you can't have any negative. If you have an affirmative conclusion, you can't have any negative premises. So what that means is this. Again, you don't have to write this down. If a syllogism has no negative conclusions, in other words, if the conclusion is an A or an I, it can't have any negative premises. If a syllogism has 1 negative conclusion, if our syllogism is an O or an E, it can only have 1 negative premise. And since a syllogism can't have 2 conclusions, obviously, it could never have 2 negative premises, which means, like I told you last week, every single syllogism whose premises are EE, OO, EO, and OE are invalid. So when you're evaluating syllogism, you can just look at that. Check the conclusion. Is it affirmative or negative? If it's negative, just look up. Or is it OO? Is it EE? And then there you go. You've eliminated like over half of the syllogisms right there. So we're going to look at these rules one at a time. I'm going to show you how they work. But what I want you to have on this screen is that the number of negative conclusions must equal the number of negative premises. So let's do this one rule at a time. So rule number 1, in at least one premise, the middle term must be distributed. Okay, and rule number 1. So here's the syllogism we're going to look at for all 5 of these rules. All ants are insects, no insects are spiders, therefore some spiders are not ants. So remember, where does the middle term have to be in order for it to be distributed? Well, it has to be the subject of an A, the subject or predicate of an E, and the predicate of an O. So rule number 1, in at least one premise, the middle term must be distributed. What is the middle term? Ben? Insects. Okay? In this premise, is the middle term distributed in at least one of those premises?
Yes.
Which one?
The second one is an E and it's the subject of.
Yes. The minor premise is an E statement, which means the subject and the predicate are distributed. So insects is distributed. Vandernoot?
So, any I statement, it would be if there is any I statements in a syllogism.
Yes, if the 2 premises were I, it would also be invalid because the premise would not be distributed in either term. Or the middle term would not be distributed in either premise. Okay? All right. So is insects distributed? As Ben already said, yes, it's the predicate of an E. Okay? So we understand rule number 1. in rule number 1, in at least one premise, the middle term must be distributed. This syllogism passes rule number 1. Are we good on rule number 1? Let's move on to rule number 2. I'm sorry, one more thing I want you to write down. When the first rule is broken, it's called the fallacy of the undistributed middle. Each one of these rules has a fallacy accompanied with it, and you'll need to know these fallacies as well. So this means that the syllogism is making no necessary connection between its premises. So here's a bad syllogism. All beetles are insects, some insects are butterflies, therefore some butterflies are beetles. Okay? Notice our middle term, insects, is undistributed. It's the predicate of an A and it's the subject of an I. It's undistributed, which means we're not making a necessary connection between our two premises. Okay? So that's what it would look like to do it wrong. So here's another kind of visual. I've got some politicians are corrupt men. Some corrupt men are mafia members. Therefore, some politicians are mafia members. Now, is that conclusion true? Maybe. But does it have to be true based on that syllogism? No. And here's a visual representation. Here are all politicians. Even if it were true that some of them are corrupt men, okay? And if we have, here are all corrupt men, and if it's true that some of them are mafia members, we don't have a necessary connection that proves that some politicians are mafia members. So this is the error. This is what it would look like to make the error, number 1, the fallacy of the undistributed middle. Next, here's rule number 2. If a term is distributed in the conclusion, it must be distributed in its premise. Okay? So this is where it's really important to keep straight minor premise and major premise. Okay? Because if it's distributed in the conclusion, it has to be distributed in the premise. So, all ants are insects, no insects are spiders, therefore some spiders are not ants. The conclusion is an O statement, which means the predicate is distributed. In our conclusion, ants is the predicate, and ants is distributed. So wherever ants is in the major or minor premise, it needs to be distributed in a premise as well. Is ants distributed in the major premise?
Yes.
Yes, it is. Why is that, Georgia Brooks?
Because it has all grid.
Yeah, it's the subject of an A. Okay, so do we get that? In your conclusion, if your minor term is distributed, it needs to be distributed in the minor premise. If your major term is distributed, it needs to be distributed in the major premise. Okay? So in this case, ants is distributed. It's the predicate of an O, and ants is distributed in the premise. It's the subject of an A. Okay?
Oh, so the minor and major term both have to be distributed, or if it is distributed.
Yes. So if your conclusion was an E, where both the subject and the predicate are distributed, that means the major and minor term would both have to be distributed or it would be invalid. Yes?
So like on homework and tests, if we want to test syllogisms by rules, we have to go through all these rules.
Yes.
But once we see, like, if we get.
Yeah, if it breaks rule number 1, then you're done. If it passes rule number 1, but it breaks rule number 2, you're done. It has to pass all 5 rules. Okay? And really what you can do is test by the first 2 and then do rule number 3 through 5 combo. So test is the middle term distributed in one of them, is the distributed term in the conclusion distributed in the premise, and then look at the number of negative premises. So you can really combine this down into 3 rules. So this syllogism passes rule number 2. And when this rule is broken, it's called the fallacy of the illicit major or the fallacy of the illicit minor, depending on which one of those terms didn't get distributed when it was supposed to. So look at this syllogism here. Some ants are not insects. Which term is distributed in the conclusion?
The one that's distributed.
Which term is distributed in the conclusion? It's an O statement. Insects. That's the major or minor term. Which one?
It's the major.
It's the major term. So I check up in my major premise. Is insects distributed in the major premise?
No, because the subject of an I and
Nope.
neither of those are.
So therefore, that is the fallacy of the illicit
Major.
major. That's the fallacy of the illicit major. Okay, I'm going to walk through that again. you find the distributed term in the conclusion. And then you check to see, is that term distributed in its premise? In this case, it's insects. And when you see that that's the major term, you check the major premise. Insects is not distributed because it's the subject of an I. Therefore, that's called the fallacy of the illicit major. Okay? Questions about rule number 1 or rule number 2?
For 2, so if it's okay if it's only one of them that's distributed. Like if that's only the major and
Well, as regards rule number 2, whatever term's distributed in the major or in the conclusion has to be distributed in its premises.
Oh, okay. So if it's both of them, they both have to.
Yes.
Okay, so only one of them has to be distributed. What if they're not?
Well, if the conclusion is an I, what does rule number 2 say? If a term is distributed in the conclusion, it must be distributed in its premise. Right. So if the conclusion is an I, it can't break rule number 2. It might break another rule, but it can't break rule number 2. Yes.
So like if you want to figure out if something's distributed, would you just look at that square right there? I guess just
Well, yeah, you can look at that square, or you can remember, whatever you want to do. But yeah, however you want to work that out. All right. As Curran has already asked, if your conclusion is an E, that means the subject, which is the minor term, and the predicate, which is the major term, need to both be distributed in the major and the minor premise. So rule number 3, a valid syllogism cannot have 2 negative premises. This one's not super complicated, right? So let's ask this question. Does our sample syllogism pass that rule?
Yes.
Yes, it doesn't have 2 negative premises. Okay, so this is as simple as counting 1, 2. If you see 1, 2 negative premises, it's broken rule number 3. If you see 0 or 1 negative premises, it might be invalid, but it hasn't broken rule number 3. If this rule is broken, it's called a fallacy of 2 negative premises. Okay? So our sample syllogism, all ants are insects, no insects are spiders, therefore some spiders are not ants, has passed rule number 1, it's passed rule number 2, it's passed rule number 3. Do you have any questions about rule 1, 2, or 3? Karen?
Can you test for validity on all these? Because it says if it's valid, or all these valid. Like all the.
Here, he's testing validity.
I'm testing for validity. I'm testing that one syllogism for validity,
Okay.
and it has to pass all 5 of these tests. Okay, so we've now passed the first 3 tests. Here's rule number 4. A valid syllogism cannot have a negative premise and an affirmative conclusion. Yep.
Can you just like combine these notes because you said 3.5, so do you have to write out?
If I underline and put it in bold, I want you to write it down. So in syllogisms, affirmative conclusions require all affirmative premises. So the way you do this is you check the conclusion. If it's affirmative, check to see if either premise is negative. If one is, it's called the fallacy of a negative premise and an affirmative conclusion. So here's our sample syllogism. Let me check the conclusion. Some spiders, not ants. Is that negative or positive? Or negative or affirmative, sorry. Is that negative or affirmative?
Affirmative. No, negative.
It's negative. So, can it break this rule?
Yeah.
No. It can't break this rule because the rule is it can't have a negative premise and an affirmative conclusion. This has a negative conclusion, so it can't break rule number 4. So does it break rule number 4? Nope. So we are now 4 for 4. Our syllogism, all ants are insects, no insects are spiders, therefore some spiders, not ants. We are 4 for 4. We've passed all 4 rules. We have 1 left to go. The tension is building. Sadler is on the edge of his seat. He can barely stand it. So let's get to the end and see, does this syllogism pass muster? Vandernoot? Okay, keep writing.
Intense music.
Yes, final countdown. Stop. All right, rule number 5. A valid syllogism cannot have 2 affirmative premises and a negative conclusion. So a negative conclusion in the syllogism requires at least 1 negative premise. So to test by this rule, once again, check the conclusion first. If it's negative, check for a negative premise. If both premises are affirmative, it's committed the fallacy of two affirmative premises and a negative conclusion. So, is my conclusion affirmative or negative?
Negative.
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 Is there at least one negative premise up there?
Yes.
Yes. So does this pass rule number 5?
Yes.
Yes.
Yay.
Thomas, read rule number 1 to me.
In at least one premise, the middle term must be distributed.
Okay, my middle term is insects. In that premise, or in those premises, is insects distributed at least once? So number 1 is good, right? Okay, Sadler, read rule number 2 for me.
If a term is distributed in the conclusion, it must also be distributed in the premise.
Okay, Sadler, what's the distributed term in the conclusion?
Ants.
Ants. Ants is the major term. Is the major term distributed in the major premise?
Yes.
Yes, it is. So rule number 2 is good. McKeever, read rule number 3 for me.
Valid syllogism cannot have two negative premises.
Does this syllogism have 2 negative premises, McKeever?
No.
Nope. Rule number 3 is a go. Charlie, read rule number 4 for me.
Valid syllogism cannot have a negative premise and affirmative conclusion.
Do I have an affirmative conclusion?
Yes.
Some spiders are not ants. Do I have an affirmative conclusion?
No.
Nope. So I can't break rule number 4, so I'm good. Gracie, read rule number 5 for me.
A valid syllogism cannot have two affirmative premises and a negative conclusion.
Okay, do I have a negative conclusion?
Yes.
Do I have 2 affirmative premises?
No.
So rule number 5 is good. Okay? So yes, this syllogism is valid. Now again, we're not talking about truth. I haven't said a word about whether or not those statements are true. I've just said this form, which is what? This form is an A, E, O,
Four.
4.
I knew it.
AEO4 is valid. Every AEO4 in the universe is a valid syllogism. Okay? Now, your homework for tonight has nothing to do with the rules. It's just on distributed terms. We're going to do the rule stuff together tomorrow. Your homework for tonight, number 1 asks what is a distributed term. Feel free to use your answer from your catechism. 2 through 8 gives you individual statements and says underline the distributed terms in the following statements. So do just that. Underline them or circle them. I don't really care. And then number 8, 9 and 10, underline the distributed terms in the following syllogisms. They give you 2 syllogisms, underline or circle all the distributed terms in each of those statements. Okay? Sophie and Gracie are going to come give these to you guys. You all can pack up. It's been a lovely audience.
Yes.
We'll work on these rules tomorrow.
Valid.
What? 3.
Valid.